I am Ennemcien. We have seen two types of polarization, namely electronic polarization or polarization of a single atom. The other is ionic polarization. In these two cases, the molecule or atom does not have an intrinsic dipole moment, or these two are not dipoles before placing in an electric field. Now there is another case where the molecule already has a dipole moment. Such molecules are called polar molecules. Each molecule has its own dipole moment. See this figure. So this is a polar molecule and this is a dipole. And this is placed in an electric field formed by two parallel metal plates, one positive connected to the positive of a battery and the other connected to the negative. And the electric field is directed from the positive plate to the negative plate. Suppose that this molecular dipole is making an angle theta. We have seen that in such case, a couple will appear and it will turn the dipole to bring its axis parallel to the field direction. Now, what does it have in connection with polarization? Suppose a block of a body in which molecules have intrinsic dipole moments. Before placing in the electric field, the dipoles may have random orientations. That is, they are scattered such that their dipole moments are in different directions with respect to the electric field we are going to apply. When such a slab is placed in the electric field, each dipole experiences a couple and it will become parallel to the field direction. See this one dipole, its negative ion will face the positive plate and positive ion will face to the negative plate. In this array or layer of dipoles, almost all the dipoles are aligned parallel to each other, and this dipole at this end will have its positive charge facing the negative plate and negative charge facing the positive plate. Well inside the slab, plus and minus of adjacent dipoles come too close to each other so that they cancel each other, producing net zero charge. This process continues throughout the layer, leaving a free negative charge at this end and a positive charge at this end. All other charges would be cancelled. This happens throughout the slab. What is the net result? A net negative charge distribution will appear on this face and a net positive charge will appear on this face. This is one kind of polarization. The slab itself is polarized because of the origin of the couple on each dipole and turning it to bring it parallel to the applied electric field. Now there are two electric fields. One, the applied field of intensity is 0. The other is these two phases act as two parallel plates with the positive charge distribution on this face and a negative charge distribution on this face. As a result, there is another electric field created. These charges are called induced charges, and these induced charges on the two opposite phases create a new electric field which is directed from this to this side of the slab, that is just opposite to the applied electric field is 0. Let it be E dash. So inside the dipole slab, inside the slab, a new field is set up, E dash, which is opposite to the applied field. Therefore, net field inside the slab or resultant field inside the slab becomes E0 minus E dash, or the field strength is reduced because of this rearrangement of the dipoles under the influence of the applied field. This is the third kind of polarization, and this is known as orientational polarization. So there are three kinds of polarizations. 1, electronic polarization. 2, ionic polarization. 3, orientational polarization. We will see the details and the effect in the next postings. Thank you.